Have you ever stopped and wondered how some things just explode out of nowhere, while other things just seem to quietly fade away? Well, it turns out there's this hidden engine behind it all, a mathematical principle that's shaping everything from your bank account to the way ideas spread online. So let's dive in and really uncover the secrets of exponential change.
Okay, I know. It's a weird question, right? A viral video just skyrockets in popularity, and a new car, well, it starts losing value the second you drive it off the lot. But here's the thing. They're both being driven by the exact same mathematical force, just running in opposite directions. And if you can understand that one principle, you'll get everything we're about to cover.
So to really get to the heart of this, we've got to start with a super simple, but honestly a pretty mind-bending idea: the power of doubling. This is the foundation, the bedrock that makes exponential change so incredibly powerful.
The key here isn't just adding things up, it's about acceleration. See, we're not just adding one each time, we are doubling the entire pile with every single step. It starts out slow. 1 becomes 2, 2 becomes 4, it almost feels like nothing's happening. And then bam, it just takes off. This accelerating rate of change is the secret sauce, and it's something our brains, which tend to think in straight lines, have a really hard time wrapping our heads around. So this powerful engine can build things up, but it can also tear them down. The best way to think about it is like two sides of the very same coin. You've got growth and you've got decay. Let's take a look at how each side really works. First up is growth. Now, the crucial thing to get here is that we're not adding a fixed number, like adding $100 every year. No, instead, we're adding a fixed percentage, like 5% a year. And that means the amount you add gets bigger and bigger every single time, which causes that explosive acceleration we were just talking about.
And on the flip side, you've got exponential decay. It's the perfect mirror image. In this case, a quantity loses a percentage of its value over time. It's the same role, a consistent percentage change. It's just being applied in the opposite direction.
Yeah, this really lays it out perfectly. For growth, the number we're multiplying by is bigger than 1, so it pushes the value up. For decay, that number is less than 1, so it brings the value down. The core engine is exactly the same. The only thing that's different is which way we're going. So how do we actually calculate all this? Well, believe it or not, it all comes down to one really elegant and surprisingly simple formula. Think of it as the master key that unlocks both growth and decay. And here it is. This is the engine room. Now, I know it might look a little intimidating at first glance, but I promise every single part has a simple, logical job to do. Let's just break it down piece by piece.
First up, we've got A. This is just where you begin. It's your starting point. It's the initial deposit in your savings account, the original price of your car, or maybe that one person who first shared a viral video. It's the foundation.
Next is R, the rate. Now, this is the power behind the engine. It's the percentage that's driving the change, whether it's a 2% interest rate or a 15% depreciation rate. This number, which we always write as a decimal, is what determines how fast things are going to grow or shrink. And finally, we have T for time. This might just be the most important part of the whole thing, because time is what allows the magic of compounding to really kick in. Our brains almost always underestimate its power, but the longer you let this engine run, the more absolutely dramatic the results will be. So how does the formula know whether to build things up or break things down? It's all in that little plus or minus sign. If you want to figure out growth, you add the rate. If you want to figure out decay, you subtract it. One simple switch controls the entire direction of this incredible force. It's that easy.
Okay, now that we've got the formula down, let's go explore the real world. We'll start with the exciting side of the coin, the amazing applications of exponential growth.
This is where it all gets real. You see it everywhere. In finance, with compound interest making your savings grow faster and faster over time. You see it in biology, with bacteria colonies or even human populations just exploding in size. It's the principle that lets tiny things become absolutely massive, and it's the key to understanding everything from viral marketing to major tech disruption. And it's not just a simple line on a graph. Exponential growth fuels the creation of these unbelievably complex, interconnected systems. Just think about the internet, or social networks, or how an idea spreads through a population. They all follow this exact pattern of accelerating, expanding connections. Okay, so let's flip that coin over and take a look at the other side. Let's see how that very same engine works to reduce value and break things down over time.
Now, it might not sound as exciting as growth, but decay is just as much a part of our daily lives. It's the reason your brand new car is worth less every single year. It's how scientists can date ancient artifacts using radioactive half-life. It's even why your phone's battery seems to drain so much faster during that last 10%. So, the big takeaway here, the one thing I really want you to remember is this. Decay is not some separate force. It is the exact same engine of change that drives explosive growth. It's just been put into reverse. If you understand one, you automatically understand the other.
From our money to our technology to biology itself, this hidden engine is constantly working all around us. It's a fundamental rule of how our world operates. So the real question isn't just about what it is, but now that you know the secret, how will you use it? How will understanding it change the way you plan for the future, make decisions, and just see the world around you?